In this lecture I want to talk about the limits to adaptation, as well as saying that there are barriers to adaptation and that some actions can make things worse. It's also important to recognise that under very high rates of climate change, adaptation might not be effective. There's a prevailing idea that 2 degrees of climate change is the level of dangerous warming. Now that is a fairly subjective interpretation. For the small island states, they tend to say it's 1.5 degrees of warming above pre-industrial levels. That has led to this idea that 2 degrees of warming is about what we should be anticipating and seeking to adapt to, which is a significant fallacy. It would appear very likely under current rates of emissions, and given what we know about how long it's going to take to slow down emissions, that we'll be looking at least probably 4 degrees of warming above pre-industrial levels. That's a lot of warming, and that's a lot of ecological change. It's a long time away. It's perhaps 100 years or so away. But if we think forward to this horizon and we think about what a world of 4 degrees of warming would be like, then we begin to think that adaptation, if we get to 4 degrees of warming, may not be able to avert all the impacts of climate change, not by any means. And we've really, I think, only begun to think about this, about the limits to adaptation, about what adaptation can't do. I said we thought that there's an impression that it's sort of easy and manageable and good, that it's less likely to be that way. But it may also just not be able to avoid certain kind of impacts, some of which are very important to us. And this is really the critical long-term issue for islands as well. Under very high rates of warming into the future, even if we do everything right, will adaptation work? The concept that's talked about here are the limits to adaptation, and they're defined as the thresholds or the points beyond which even the best efforts to adapt don't avoid impacts. And there are various kinds of limits or various kinds of these thresholds that are worth thinking about. 4 kinds. First, talk about ecological or physical thresholds, a point in which an ecological system just changes or ceases to exist or changes in a very fundamental way because of the rates of warming. That's probably the case. Some of the best science on coral reefs suggests that at about 2 degrees of local warming at the place where the reef exists, which in a tropical Pacific means maybe 2.5 degrees of global average warming, coral bleaching will occur annually, and severe coral bleaching will occur about every 4 years. Now, there may be nothing that can be done to avoid that level of coral bleaching. The impacts of that on fish species, on the morphology of islands may be very significant in the long term. There may be less fish. The long-term ability of islands to adapt to rising sea levels may be seriously compromised. There's evidence that shows that well-managed reefs on uninhabited islands are much less prone to bleaching, and that would appear to be certainly one option. The better management of reefs and land-based forms of pollution and fishing and the use of reefs could certainly reduce their susceptibility to bleaching during episodes of high sea surface temperature. But ultimately, at very high rates of warming, maybe those activities won't work either. And an island without a reef, particularly an atoll island without a reef, is probably not going to be an island for very long. And really, there's not much we can do about this. Another example is about snow, and that there are various forms of plants and animals that rely on seasonal snow for their cycles and breeding cycles and so on. And so when there's no snow, which is certainly seems very likely in the Australian alpine areas, there's a series of unique flora and fauna that are dependent on snow and an annual snowfall for their existence, and we may lose these species. A lot of concern about a mountain pygmy possum, which is one such species. Probably nothing we can do. We can take its genes, we can keep them in a zoo and create artificial habitats for the mountain pygmy possum, but it in the wild may cease to exist under very high rates of climate change. These are limits to what adaptation can achieve in these examples. There are economic limits, and I've talked a bit about these already, where adaptation is just going to be too expensive. Nobody's going to pay it, particularly relative to the cost of the impacts that might be avoided. There is a limit to how much people will spend to protect places from sea level rise or to sustain small farming enterprises and to continue to provide them water. And that money won't be spent and those impacts will be incurred. There is a proposal, for example, too, about reefs, that if we could shade reefs and reduce some of the UV light, that might increase their ability to withstand climate change, the impacts of climate change and ocean acidification and bleaching events. But it's not economically feasible to shade every coral reef in the world, or even those ones that are most important. That's a lot of land area. There are technological thresholds too, things that where the existing technologies that we have are not going to work as adaptations anymore. And snowmaking is a very good example of this. This is the Australian Alps, where most years snow guns have to operate to manufacture snow for the ski fields. And it's a economically lucrative industry. People like to go skiing. It takes water and it takes cool air to make snow. The limit, and it takes energy. And energy is going to cost more. There may be less cool nights in which it's able to make snow, but the biggest constraint, it would appear, is a lack of water to manufacture snow. The technology, as far as we know, isn't going to work to continually provide snow cover for the ski tourism industry long into the future under high rates of warming. Finally, there are social limits. Responses that some groups do not consider to be responses, or responses that don't seem to work. And the example of migrating from islands, or forced migration from islands, would clearly be a social limit to adaptation to many people. This wasn't an adaptation, it was an impact. There are potential, for example, for genetic modification of certain species to enable them to be more adaptable to warmer temperatures. But some people would be highly opposed to the idea of genetically modifying coral, or specific breeding programs to change the composition of coral reefs so that they continue to exist. There's a moral and ethical problem there. And there are some things, there are some losses that can't be substituted for. An individual might lose their form of income because of climate change, they lose the farm, but you can substitute their income in certain ways or restructure their livelihood so that they can continue to live on the farm and make money, in theory. Monetary things and material things can, in theory, be compensated for. People can lose their businesses, industries can restructure, and so on. But non-monetary things, the things that give meaning to life, communities, values, places, cultures, and so on, there may be no substitute. There is a direct limit to adaptation. There's nothing that can be done if the sea levels rise by 2 metres and corals bleach annually and you live in Tuvalu. There's no acceptable solution, potentially, if you lose your home. So it's useful to think about the limits to adaptation for a few reasons. When you begin to research what sorts of solutions are feasible and practicable in any given place in response to any given risk, begin to get a better idea of what might and might not work, and who might agree and who might oppose certain kinds of responses. Ask people about seawalls and see what sort of answer you get. You get a range of responses. For some people, clearly they're an unacceptable adaptation. For others, clearly they're too expensive. For some, they're a very good idea. It also begins to help asking about the limits to adaptation to understand the significance of potential loss. That when people say, well, there is no acceptable adaptation to me for the loss of a reef or the demise of a species, that's just a loss. Trying to map those potential losses and think about which ones we really need to try and avoid if we can, which ones could be compensated for and managed, and which ones just going to have to take a hit on. Just going to lose these things, maybe. And it's not nice, but it may help to try and anticipate what these problems are into the future. There's something also very important about investigating the limits to adaptation, because they all arise under conditions, and they're more likely to arise, and we're likely to hit many, many limits to adaptation across many places and sectors under very high rates of global warming. So one of the things that focusing on the limits to adaptation does is show us that a really important part of adapting to climate change is reducing emissions so that the rate of warming is slow and doesn't reach a high level to enable us to adapt to change. If we can't slow warming, change is going to be very high, adaptation will reach its limits, and we will incur all sorts of impacts of climate change. So it folds us back. Mitigation is a very important part of climate change adaptation, reducing emissions. And the economists have shown this in various ways too, that early action to reduce emissions, the net cost to society of early actions to reduce emissions, are far lower than having to adapt to the impacts of climate change later in time. It's more economically efficient to reduce our emissions than to pay the full cost of adaptation. So adaptation isn't going to be able to avoid all climate risks. It is a time game. It is about the speed and the magnitude of change, and under very fast rates of warming and very high rates of warming, adaptation will reach its limits, impacts will be incurred. Adaptation cannot be a substitute for mitigation. We can't adapt our way out of the problem of climate change. We must have mitigation. We must significantly slow the rate of global warming if adaptation to be effective, and we're going to be able to protect the things that we value collectively and as individuals. Without mitigation, we can't rely on adaptation to solve all our problems. And adaptation is only sometimes cheaper than mitigation. In the long term and at an aggregate level, reducing emissions of greenhouse gas emissions is a very cost-effective form of adapting to climate change.